Curvilinear coordinate systems 11, a second toroidal system using coordinates psi, eta, and phi can be formed with these coordinates related to the Cartesian coordinates by this set of equations. And part A says describe the surfaces of constant psi and constant eta, and part B, pick a point and sketch the basis vectors. Is this a right-handed system? Now, last time we did part A, so we have found the constant psi surfaces and constant eta surfaces. Constant psi surfaces are spherical balls centered at 0, 0, A, cotangent psi 0, with radius A over sine psi 0, and constant eta surfaces were these toroids given by this expression. And looking at this website here, Mathematica, we can see a sketch of this for psi equals pi over 2 and psi equals 3 pi over 2, and eta is equal to 0 and eta is equal to infinite. So these are our toroids here, and you can see the unit vectors e psi hat, e eta hat, and e phi hat. And now you can notice that for the system consisting of psi, eta, and phi, which was the way this was defined, psi, eta, and phi, e psi hat cross with e eta hat is what we need to look at to decide if this is a right-handed coordinate system. E psi hat cross with e eta hat gives us a vector that's pointing in minus e phi hat direction. Therefore, this is a left-handed coordinate system. Now, to make things clearer, I have listed, so I've set A is equal to 1, and I have listed a set of values for psi and a set of values for eta. You can see here, using this contour plot 3D, we can plot the constant psi and constant eta surfaces. This is the code for constant psi surfaces, and this is the code for constant eta surfaces based on our results from part A. Now, constant psi surfaces give us these spherical balls. This basically corresponds to psi is equal to almost 0. This is the plane, the xy plane. And you can see that the center of the ball changes depending on the value of psi. And for constant eta surfaces, we have these toroids. So these are changing values of eta in between 0.8 and 2. You can see we have these toroids. So if we plot them together, these are constant psi surfaces, these are constant eta surfaces. And if you take a cross-section of this, this is basically what we obtain here. So we have these spherical balls and these toroids as sketched on this website. So where we have shown the unit vectors e psi hat, eta hat, and e phi hat. So once again, this is the end result for using a contour plot, three-dimensional contour plot. These are constant eta surfaces, these are constant psi surfaces. And if I take a cross-section of this and look at it from the YZ plane, and this is my X coming out of the plane, I obtain this plot, which is shown on this website, and the unit vectors that are shown here basically suggest that this is a left-handed coordinate system, because e psi hat, e eta hat, e phi hat, if I go over cyclic permutations here, these cross products are giving me minus of the unit vector.